often to wrap my mind around problems like this, I need to draw a picture. So I'm going to sketch this situation out to try and solve it. So I want to try to find the total distance traveled during these seconds using the idea of a left endpoint approximation. And to identify what the heck a left endpoint approximation is, a picture helps enormously. So let's throw a graph down here. And let's make this be 1, 2, 3, 4, 5, and 6 there. And then for the velocity, let's see, the low is 2 and the high is 33. So maybe I'll go 10, 20, 30. And so let's plot some points now. 0 goes with 18. That would be about there-ish. 1 goes with 32. That's about here-ish. 2 goes with 33, just a touch higher, about there. 3 goes with 20. Oops, I put that in the wrong spot. 2 goes with 33. 3 goes with 20. 4 goes with 5. 5 goes with 2. And 6 goes with 13, about right there. And again, this axis here is my velocity, and this one right here is my time. And we're approximating total distance here. And remember, distance equals rate, or velocity, times time. So for the first second that goes by here, using the idea of a left endpoint, so the left side of that first second is that 18 miles per hour. So we're just going to assume it moves 18 miles per hour for that whole first second. And then if I take that 1 second times that 18 miles per hour, that's this area right here. And that area is also the distance covered. And then for the next second that goes by here, left endpoint means assume that it moves this speed all the way across there. Ooh, that was a shitty line. Let's try that again with a straight line. There we go. And then here, we'll assume it moves 33 miles per hour. And then for this next second, we're going to assume it moves 20 miles per hour, and then 5 miles per hour. And then for the last second, we're going to assume it moves 2 miles per hour. And since there's just 1 second that elapses between each of these, 1 times 32 is 32. So this distance is going to be 32. Oops. Switch colors. Actually, let's erase a little bit here. So again, the area in here is 1 times 18, which is 18. Right, because time times velocity, this is the velocity axis, gives me this area, which is also the distance. This distance here is going to be 32, and the distance here is going to be 33, and the distance here is going to be 20. This distance is 5, and the final distance here is 2, because this rectangle is 1 by 2. So it turns out I want to add up these numbers right here to get the total distance covered. And again, this is a Calc 2 type problem, so these are the kinds of things you're going to do next quarter. I hope that was helpful.